Hello class, today we're going to talk about repeating decimals to fractions. Now the last lesson we worked with some other kind of decimals. We learned how to convert a terminating decimal and a repeating decimal if the whole decimal is repeating back to its decimal equivalent. So what about a terminating decimal? Now we know a terminating decimal is a decimal that stops, like 0.25, 0.37, one that doesn't go any further. So how do I change it into a fraction? Well, you just say it correctly. So if I gave you 0.25, we would say that is 25 hundredths. So we would write that as 25 over 100 and then simplify. Now what if I gave you a repeating decimal? Now we learned yesterday that we do something called the 9 thing. Okay, where what we will do is we will place the decimal in the numerator, the whole decimal in the numerator, and we'll place a 9 in the denominator for each number that is repeating. So let's see if we can practice that. So the first one is 0.45. This is a terminating decimal because it does not repeat. It has no bar. So what we do on this one is we just say it correctly. 45 hundredths. So we write it as 45 over 100. And then we simplify that. Now in this particular video, I'm not going to focus on the simplifying because you can type this into your calculator and it simplifies. Okay, but if we did simplify this one by hand, the 45 and the 100 both have a 5 in common. We simplify that, it turns to 9 over 20. But I'm not going to focus on the simplifying in this particular video. Now, the next one is 0.7 with a bar. So we know that 7 repeats. Now, if you look back at what the instructions said for a repeating decimal, you're going to place the decimal in the numerator. So I'm going to take that 7, we'll place it in the numerator. And it says I'm going to put a 9 or place a 9 in the denominator for each number that's repeating. Well, in this particular one, there's only one number repeating, so I put a 9. So we got 7 over 9, and that would be the fraction equivalent of 0.7 with the bar. Now the last one, 0.745, where the whole thing is repeating. Well, if we follow that instruction, we put the 745 in the top, and we put a 9 for each number in the bottom, or that's repeating, sorry. For each number that's repeating. In this case, there's 3 numbers repeating, so that means I'd put 3 9s. And then we would type that into our calculator to simplify. Okay? So that's what we did when we had a terminating decimal where nothing repeats, or when the entire decimal repeats. But what if I gave you some like this, where the whole thing doesn't repeat, only part of it repeats? Well, we have to modify our 9 rule just a little bit. In this particular one, what we're going to do, there's a 2-step process. For the numerator, what we're going to do is we're going to find the difference of the entire decimal, of the whole decimal, and the number formed by the non-repeating parts of the decimal. For the denominator, we're going to put a 9 for each repeating digit of the decimal and a 0 for each non-repeating decimal. For the example that I gave you is 0.342 with the 42 repeating. We take the whole decimal, 342, and we subtract the part that's not repeating, the number formed by that. In this case, we just have the 3. So 342 minus 3 gives us 339. And then I put a 9 for each repeating digit, the 4 and the 2, and a 0 for the 3. And then we simplify. So let's go back to that page. Let's see if we can do this. Now again, I'm not focusing on the simplifying. I'm just focusing, can you get the fraction equivalent? Okay, so the first one, we got 0.16 with the 6 repeating. So for my numerator, I'm going to take the whole decimal, subtract from that the number formed by the non-repeating part, the 1. So 16 minus 1 equals 15. Okay. For the denominator, I take the 6, because it's repeating, I put a 9 for it. And the 1 is not repeating, so I put a 0. So we end up with 15 over 90, and we simplify. Hopefully you recognized 0.16 with the bar on the 6 as being 1/6, because that's one you're supposed to be memorizing. Okay, so the next one, we've got 0.45 with just the 5 repeating. So we're going to take the 45 and we're going to subtract the part that's not repeating, the 4. Okay, and we end up with 41. Okay, and we have one repeating number, that's a 9. We have one non-repeating, that's a 0. So it's 41 over 90. Now this last one's the toughest one. Let's see if you can do it. We've got 345 with the 5 repeating. Okay, so our top number is going to be 3. Where did the 2 come from? 3 4, 5, minus the number formed by the non-repeating part, which is 34. Okay, so that becomes our top number. Now, what we may have to do is come over to the side and subtract that, and you can do that on your calculator. Okay, so I subtract to get 1, I end up with 311. And then on my bottom number, I have one number that repeats, two numbers that don't repeat, so I end up with 311 over 900. So in order to write a repeating decimal where only part of the decimal repeats, for the numerator, you find the difference between the whole decimal and the number formed by the non-repeating parts of the decimal. For the denominator, you put a 9 for each repeating digit and a 0 for each non-repeating digit. Now, this also works for the ones that we just did. So if I were to come back to one of the problems that we just did, take for example this first one. If we use that same rule, okay, first part is take the 745, write the whole thing down, subtract from it the number formed by the non-repeating parts. Well, there aren't any, so I subtract 0. Okay, and I look at for the denominator, I see there's 3 numbers repeating. I put 3 9s. There are no numbers that aren't repeating, so I don't put any zeros. So it still works the same way. So this rule works for all of it. So all we have to do, numerator, find the difference between the whole thing and the part that's formed by the non-repeating part. And for the denominator, put a 9 for each repeating digit and a 0 for each non-repeating. Until next time.